13-3, radians. Radians. So let's define what is 1 radian. 1 radian. Okay? Radian is an alternate to degrees. Right? Instead of measuring things in degrees, we've been measuring things in degrees so far, like 30 degrees, 90 degrees, 120 degrees. We're going to start measuring things in radians now. We have to define what is a radian. A radian is not a degree. Right? It's the angle it's the angle needed to intercept, right, the angle needed to intercept an arc of length r. And r stands for radius. Okay, 1 radian is the angle needed to intercept an arc of length r, or radius. And that part doesn't make any sense right now. But if I draw a picture, I think it will. So let's say we've got, again, our unit circle here. So let's just draw a little rough circle here. Alright, so we're measuring things not in degrees, but radians. So let's say this is a unit circle. It doesn't have to be. It could be radius 2 or 3. But let's say this is radius 1. Right? Let's say this is a unit circle. 1 radian is the angle necessary needed to make the intercepted arc. That's the arc that I get to see as I'm opening up to it. So like, for example, at this angle right here, the intercepted arc is like this length. It's like that. Okay. Do you guys think this line right here, this arc, if I stretch it out, is equal to 1, the length of the radius right now? No, it's too short, right? What if I lengthen it to like right about there? If I stretch it out, would this equal the radius? Almost. Maybe not quite. Not quite. So you're going to actually have to go a little bit past halfway. A little bit past halfway. About here, if I stretch out this arc, make it straight, it's going to equal 1. If I stretch it out, this length would actually be 1. And it doesn't have to be just a unit circle. If this was 2, this would have to be 2. If this was 3, this would be 3. But for these to be equal, that is a radian. Right? The radian is this angle formed. We shoot this right through here. It's this angle formed right here. Let's go ahead and just form an angle. It's the angle formed where this length of this arc that's intercepted is equal to the radius. If it's 1 and 1, if it's 2 and 2, this angle right here, right? We'll call him theta. Right? We use theta for angles. Theta is 1 radian. Right? Theta is 1 radian. 1 radian. Okay, so it's not a degree, it's radians. Right? The word radian, notice that the radi part, it's very similar to the word radius, right? So let's think about how many radians are in a full 360 degree circle. Right? It looks like it's about maybe 5, something or like that. This angle, as it turns out, 1 radian is approximately equal to 57.3 degrees, approximately 57.3 degrees. It's a little bit past halfway, So if I multiply this out, 5 times of these would be about 200 and something. 6 of these, let's see, 6 times 5 would be 300, 6 times 7, 42. It's a little bit over 6. It's a little bit over 6. And to see exactly where this number comes from, think back to geometry, guys. Think back to geometry. What do you call the outside? If you measure this length, the perimeter, what do we call the perimeter of a circle? The circumference, right? What is the formula for the circumference of a circle? It's C equals 2 pi r, right? Pi r squared is the area. 2 pi r is the circumference. Okay, so 2 pi r, in this case, would be just 2 pi 1. The circumference is 2 pi. The circumference is 2 pi, right? But notice that these are equal, right? These are equal. So if this is going to be 2 pi, then the angle that forms them, the angle that forms all the way around, is also going to be 2 pi. So to go all the way around the circle, all the way around, is going to be 0 at the beginning. It's going to be 2 pi at the end. 2 pi radians is all the way around. So let's go ahead and just write that. A full circle, right, 360 degrees, is 2 pi radians. A full circle is 2 pi radians. Okay, well, based off of that, then we can make a whole bunch of other things that we can figure out. So if all the way around is 2 pi, halfway around, guys, half of that would be, what's half of 2 pi? 1 pi, right? So 180 degrees would be 1 pi, or just pi. Right, this is 2 pi all the way around, so 1 pi is halfway around. Well, let's think about this. Just like 180 degrees is half of 360, 90 degrees is half of 180, so this would be half of 1 pi. Half of 1 pi would be pi divided by, how do you half something, guys? You divide it by 2, right? So 90 degrees is pi over 2. And then for 270 degrees, the quickest way I just count, well, this is 1 pi over 2. This is 2 pi over 2, right? 1 pi. Therefore, this must be 3 pi over 2. Right? 1 pi over 2, 2 pi over 2, or 1 pi, 3 pi over 2. Therefore, all the way around would be 4 pi over 2. 4 pi over 2 is just 2 pi. Okay? This is a radian. Okay? We're going to talk about how to convert them, and then we'll find sine and cosine to finish up today. So, we know how to find these guys. These are the basic ones. 0, pi over 2, pi, 3 pi over 2, 2 pi. What are all the in-between ones? And the way that we use that to convert between degrees and radians, use the fact that 180 degrees equals pi radians. Okay, to convert, use the fact that 180 degrees right here equals pi radians. 180 degrees equals pi radians. So we're going to convert by making a fraction, and I think it'd be easy if we just see it. So first off, let's convert to degrees. Let's convert to degrees. So first off, let's say I've got pi over 4 radians. Pi over 4 radians. And I want to convert it to degrees. What you do is you use the fact that 180 degrees equals pi radians. So we're going to multiply by either 180 degrees over pi or pi radians over 180 degrees. Now, because they're the same, I want the radians part to become 0, or to become 1, and cancel out. So I'm going to multiply by pi underneath, right? Pi radians on top, pi radians underneath, and then 180 degrees is going to go on top. And if I do that, I will be left with the pi goes away. I'm left with 180 over 4. 180 over 4, which if I divide them both by 2, I mean, you can do this all in your head if you want. I can divide them both by 2. I get 90 over 2. And 90 divided by 2 is 45 degrees. So pi over 4 is 45 degrees. Pi over 4 is 45 degrees, which makes sense, actually, if you look at the chart, because 45 is right about there, right? 45 is right about there. So pi over 4 is half of pi over 2, right? Pi over 4 is half of pi over 2, so that makes sense. Let's go ahead and try another one. Letter B. Let's do 3 pi over 2. 3 pi over 2 radians. So again, we're going to multiply by either 180 degrees over pi or pi over 180. But because we want the radians to go away, let's multiply by pi underneath. 180 degrees on top. So the pi's become just 1 here. We're left with 3 times 180 over 2. 3 times 180 over 2. Let's think about that. 3 times 180 over 2. I could divide this. 180 divided by 2 is going to give me 90. All right, so 3 times 90. That's going to give me 200 170 degrees. The other way, guys, let's convert to radians. Convert to radians. So same thing, except we're going to go the opposite direction. Let's try 225 degrees. We'll call this letter A. So I'll do this one. I'll do AB, you do CD. So instead of multiplying to get the radians to cancel out, guys, what number should be underneath right here if I want the degrees to go away? 180 degrees, right? Degrees on top, degrees underneath. That means the degrees are going to go away. You got pi on top. This is radians, right? These are the same thing, but the radians are left over. So we've got pi. The big question is you've got 225 pi over 180. And it's kind of funky to simplify this. My trick is I like to break it down like we do in Algebra 1, like this times this times this, this times this. And most of these are going to be a multiple of either 45, 30, or 60. So in this case, this is clearly not a multiple of 30 or 60. This is going to be a multiple of 45, right? I'm going to break this down to 45 times something. Let's think about this. 45 times what gives me 225? Let's think. 45 times 4? No. 45 times 5? Let's see, 25 to... Yep. Okay, so 45 times 5 times pi. All right? I think you've seen this in Algebra 1 where you break things down. That's the same thing. And then 180, we just talked about that. That's 45 times 4, right? 45 times 4 is 180. Okay, now that I've broken it down, I can see clearly 45 over 45 makes an equivalent form of 1. So 225 pi over 180 is the same as 5 pi over 4 radians. 5 pi over 4 radians. Okay, so we just break it down. Finish copying that down. We'll try one more together. All right, let's try 150 degrees. 150 degrees. Okay, again, we're going to multiply so that the degrees are going to go away. So we're going to multiply by pi over 180 degrees. The degrees go away. So now we just got to figure out what this 150 over 180 is. Right? 150 pi over 180. 150 pi over 180. You can divide by 10 right away and get 15 over 18. You just keep dividing. But I'm just going to break it down. So let's think about this, guys. Can I break down this by 30s or by 60s? Which one? Let's see. 60 works for here, but 60 doesn't work for this one. Let's use 30s. So this would be 30 times, let's see, 30 times 5 times pi. And this would be 30 times 6, right? That's 180. So I broke it down. You don't have to do it this way. You could kind of just keep dividing it. But now we get 30 over 30, so we get 5 pi over 6. Let's finish today by bringing it all back together. Bring it all back together. And let's find the sine of, let's do something kind of more interesting, negative 2 pi over 3. Over 3. So that's going to be, we can work with this. 180 over 3 is going to give us 60. So Caitlin, how many degrees total is that going to be? Negative 120 degrees. Good. So let's go ahead and rewrite that. That's sine of negative 120 degrees. Negative. So Sandra, I'm going to rotate. Here's negative 90. How much more, Sandra, do I need to rotate to get to 120? 30 more. That's not halfway. It's like right about here. 30 more. That's 30 degrees. That's 30 degrees. So I'm going to make a triangle now. Do I make a triangle with the x-axis or I make a triangle with the y-axis? With the x, you're going to straight up here. Make this little guy right here. Okay, now if this is 30, ladies and gentlemen, fill this in. What's this angle right here going to be? If this is 30, 30 plus 60, that must be 60 degrees because the whole thing is 90. So therefore, this is your long side. This is your long side opposite 60. This must be the square root of 3 over 2. And the short side must be 1/2. And let's go and fill in our negatives. Let's see, I went left, so this should be negative. I went down, so this should be negative. Ladies and gentlemen, which one represents my sine, my y value? Is it the negative 1/2 or the negative root 3 over 2? Negative root 3 over 2.